Hello everyone. Today we have to learn about integration by parts, another method of integration. Previously we have learned about the method substitution. Now it's a time for getting integration by parts. This method will be used in a case when the functions comes in a productive form. Mean to say minimum 2 and more than 2 functions comes in a productive form, then we have to utilize this. So here is the formulation for this. Say it is u into v, they are the two function of x, and we have to integrate them. For integration of them, what we have to do, we have to choose any one of them as a first, any one of them is as a second, and there is a rule for that. So we have to find out, say it is a first and it is a second. Then integration by parts method says drop the first function, whatever the first function we are having, that function should be keep as such. So that is drop the first function, integrate the second function, say it is v dx, and then put the minus sign, integration again, differentiate the first function, that means to say du by dx, integrate the second function, mean to say integration of v dx and whole integration again. That is the rule for us. This rule defined as integration by parts. I repeat what the rule is. When two functions are there, any one of them we have to suppose first, any one of them we have to suppose second, and then after rule says drop the first, integrate second, minus integration sign, differentiate the first, integrate second, and reintegrate again. That is the rule integration by parts. Now the important thing is which function should be supposed first and which function should be supposed second. For that we have a certain rules, so we have to follow them. So for the first and second, say the integration comes here u into v dx. Now which one is first, which one is second? What the rule says, the basic of that rule is what? The first function, mean to say it is u, should be what? Differentiable. The first function should be differentiable, and the second function, say it is v, it should be integrable. Means message is very simple. We should choose that first function whose differentiation we are comfortable, and second function should be choose whose integration is comfortable. That basis on that we have to choose first and second one. Apart from this theory, we have a certain theory also, and that theory defined as Eilert principle. That is ILATE, Eilert principle. That Eilert principle defined the first and second location of the function. What does stand by for? I, that is stand by for inverse T ratio. Inverse T ratio, that is for I. L, that is for logarithmic function. That is logarithmic function. A, that is stand by for algebraic function. That is stand by for algebraic function. T, stand by for trigonometry function, trigo. Fine. And finally E, stand by for exponential function. So there is a principle Eilert. What? Eilert stand by for, I repeat, I for inverse T ratio, L for logarithmic, A for algebraic, T for trigonometrical function, E for exponential function. And rule says the function which comes first in the sequence, that will treat as a first, and the function which comes second later, that will treat as second. But basic principle for adopting this Eilert principle is again the same what I told you people. The first function must be completely differentiable and second function must be completely integrable. So that's the theory behind the integration by parts. Now we should consider some examples for just clarify this method clearly. Say an example here, it is x and what? I'm saying it is log x and dx. That is very first function we have. Fine. So we have to find out that, say it is log function, it is algebraic function. So according to Eilert, right, L comes first, so it should be first, and algebraic comes second, it should be second. Fine. So that function should be treated as second. So before starting the question, we have to adopt it. Which function should be first and which function should be second. So we have to suppose there is log x is the first function, x will be second function. And another theory we can apply our common sense. Guys, we are very well familiar about the differentiation of log x, not familiar about the integration of log x. We can differentiate in, x as well as integrate x. So we have to suppose accordingly also. Fine. After then we have to apply the rule. What the rule says, drop the first. So dropping, integrate second, that means to say x dx minus differentiation of the first function, that means dy dx of log of x, say it is on base e, and integration of x dx, and combine the again integration, that is dx. That we have executed the result. Now further, this log x will continue as such. Integration of x comes to us is x square by 2 minus, again integration sign, differentiation of log x, that is 1 upon x. Fine. Integration of x, it is x square by 2, and what? This is dx. Now further, I should write that first. Here is x square by 2, and what it is? Log x minus, inside the portion 1 by 2 will be out and 1x will be cancelled out, remains here x dx. Now finally, we have the conclusion or results here. The result is x square by 2, here is log of x, it will be there, minus 1 by 2, integration of x comes to us is x square by 2 plus of c. So that's the integration we have by parts. Fine. Now let's take again one more example for that. This integration method can be used one time, two time, or any stage, right from the beginning or mid of the question or end of the question. Say another example here, x square e to power x dx. Now we will realize that how much time we have to do integration here. Say accordingly we have to use the first and second again. It is exponential function, this is algebraic function. See guys, highlight again, it will help us. Algebraic, that comes first, exponential, that comes later. It will be first, it will be second. So algebraic part should be first and exponential should be second. So according to highlight we can decide which will be first and which will be second. Now further we should go with that. Here is drop the first, x square dropped. Integrate second function, ex, again integrate. So I'm just writing directly, it is ex integration is ex. Minus, again integration sign. The differentiation of first function should be there. Differentiation of this function should be there. So there is 2x, right? And this integration portion carry on as such. That means ex and what? dx. That we did one time. Now next is, say here is x square into e to power x minus 2 again out and inside portion again x ex dx. Now we can realize again, here is two functions which are multiplied to each other. So again we have to suppose it is first and it is what? Second. So we have to go through with that and we have to apply the by parts method again. One more time we have to use the by parts method. So how we can use it? Just see. Here is x square e to power x minus of 2. I can take a bracket here. Again apply the same thing. Drop first, integrate second, ex integration, same ex minus a differentiation of first, that means x is 1 and this portion should continue ex and what? dx. There is. Now it is x square e to power x minus of 2. Here is x ex minus ex integration again ex and plus of what? c. Now we are able to put the results and finally our conclusion comes out. X square ex minus, it will be 2x e to power x plus 2ex plus of what? c. There is. So this method defined as integration by parts. Thank you.